Science 1, Standard 9, Topic Work and Energy. Today we will study about potential energy, transformation of energy, law of conservation of energy. Look at the following examples. An arrow is released from a stretched bow. Water kept at a height flows through a pipe into the house below. A compressed spring is released. Now, which words describe the state of the object in the above examples? Where did the energy required to cause the motion of objects come from? Now, in all the three examples, the objects are at specific state or position, and because of this specific state or position, they are having some energy stored. Now this energy is called as potential energy. So we will see in details what is potential energy. Now we will see the definition of potential energy. The energy stored in an object because of its specific state or position is called its potential energy. Try this activity. Hold a chalk at a height of 5 cm from the floor and release it. Now stand up straight and then release the chalk. Now in both the cases, the mass of the chalk is same but the height is different. In the first case, the height is 5 cm, and in the second case the person is standing and then releasing the chalk. So in the second case the chalk will break into many pieces. Now from this activity we will see that the potential energy depends on mass as well as height. If the mass is same and height is different, then the potential energy will be different. And if the height is same and mass are different, then also potential energy will be different. Now we will derive the expression for potential energy. To carry an object of mass m to a height h above the earth's surface, a force equal to mg has to be used against the direction of gravitational force. Now here the object is having mass m and it is raised above the earth's surface to a certain height h. So the force required to do this work against the gravitational force is equal to mg. So displacement will be equal to h, and where g is the gravitational constant. The amount of work done can be calculated as follows. Work, we know that it is equal to force into displacement. So work is equal to F multiplied by S. But here in F is equal to mass into gravitational force and displacement is equal to height. So instead of F multiplied by S, we can write mg multiplied by h. So work done will be equal to mgh. For your convenience, I am writing m multiplied by g multiplied by h. So therefore, the amount of potential energy stored in the object because of its displacement will be potential energy. So work done is equal to potential energy. So potential energy can be written as mgh. Therefore, displacement to a height h causes energy equal to mgh to be stored in the object. Whenever there is a displacement, so the amount of displacement will be equal to energy stored in the object. Now we will solve the example. 500 kg water is stored in the overhead tank of a 10-meter high building. Calculate the amount of potential energy stored in the water. So first we will write what is given. Here mass is given 500 kilogram, height is given 10 meter, and gravitational constant, the value of G will always be same, that is 9.8 meter per second square. It may be given in the numerical or may not be, but you have to remember its value. Now what we have to find? Potential energy. So potential energy is mass multiplied by gravitational constant multiplied by height. So we will put the values. 500 multiplied by 9.8 multiplied by 10. Now after multiplying we will get the answer as 49,000 joule. So the potential energy stored in water is 49,000 joule. Now you have to use your brain power. Here, Ajay and Atul have been asked to determine the potential energy of a ball of mass m kept on a table as shown in the figure. What answers will they get? Will they be different? What do you conclude from this? Now here Ajay and Atul are standing at different height and the ball is kept on the table. So will the potential energy be different for both of them, and why? Now here potential energy, we know it is relative. It depends upon the height. So the height of the ball with respect to Ajay and Atul are different. So the potential energy with respect to them will be different. We have already seen the different forms of energy. Now, which type of energy is used in each of the following processes? First example, a fan running on electricity. The process of photosynthesis. The crackers exploded in Diwali. Breaking of a glass window pane because of a loud noise. Drawing out pieces of iron from garbage using a magnet. So in all the examples, different types of energy is used. So in the first example, it is conversion of electrical energy into mechanical energy. In the second example, conversion of light energy into chemical energy. In the third example, conversion of chemical energy into light and sound energy. In the fourth example, conversion of sound energy into mechanical energy. And in the last example, conversion of magnetic energy into mechanical energy. Now, all these examples you will see one energy is converting into another energy. So these are the examples of transformation of energy. Transformation of energy is nothing but conversion of one form of energy into another form and vice versa. For example, electrical energy can be converted into mechanical energy, and in turn mechanical energy can be converted into electrical energy. Same way, electrical energy can be converted into heat energy into electrical energy. Electrical energy into light energy into electrical energy. Chemical energy into electrical energy into chemical energy. Electrical energy into sound energy into electrical energy. So in this way, one energy will be transformed into another form and the process will go on. So this is transformation of energy. Now we will see transformation of energy by using suitable examples. So here, engine or fan will convert electrical energy into mechanical energy. Generator will convert mechanical energy into electrical energy. Heater will convert electrical energy into heat energy. Thermocouple will convert heat energy into electrical energy. Solar cell or photoelectric cell will convert light energy into electrical energy. Electrical lamp will convert electrical energy into light energy. Primary cell will convert chemical energy into electrical energy. Secondary cell will convert electrical energy into chemical energy. Loudspeaker will convert electrical energy into sound energy. Microphone will convert sound energy into electrical energy. So these are all the examples of how one energy is transforming into another form. Now we will see this activity. We are making two pendulums of the same length with the help of thread and two nuts. Now we are tying with another thread in the horizontal position in such a way that they will not hit each other while swinging. Now, when one pendulum will swing, and what we will observe that the speed of oscillation of the pendulum slowly decreases, which means when the one pendulum is swinging, the other will be at rest, and after some time the other pendulum starts swinging. So why it is happening? Because one pendulum transfers its energy to the other. So on the basis of this, we will see what is law of conservation of energy. In the pendulum activity, we have seen when one pendulum was stationary and the other was swinging. Then after some time, the other started swinging and the one which was moving will be stationary. So what is happening? The energy is transferring from one pendulum to the other. So what law of conservation of energy states that energy can neither be created nor destroyed. It can be converted from one form into another. Thus, the total amount of energy in the universe remains constant, which means that we can't create energy and we can't destroy it. Energy can only be converted from one form into another, which we have seen in transformation of energy also. Thus, the total energy in the universe always remains constant.